Welcome, everyone. Good afternoon. Welcome to our Ames Center online series. My name is Steve Pauls, and I'm here with Elin Anderson. And we're going to talk a little bit about seed dispersal and how seeds travel. Spin, splash, soar. How do seeds travel? There we are. Plants and seeds are really amazing. Today, we're going to talk about seeds, specifically the amazing diversity of design involved in the different ways seeds can travel from their parent plant. We live in the Ames Center is in the Central Valley of California, in Fresno. And right now it is a great time to be growing things in May. And there are lots of seeds that are being produced right now. What I'd like you to do as we talk today, as we play today, is to think about the shapes of different seeds, how they differ in shape, the diversity of seeds from different plants, their different modes of travel, their design, and how they adapt depending on where they reside, whether they're near water or in the desert or in a forest. So most of all, we want to play together. And we do that really through 4 steps at the Ames Center. Number 1, we want to observe. How do seeds differ in their design? A little later on, we're going to do an activity where we build paper helicopters. And the question to ask is, how does a paper helicopter look like a seed? Number 2, we want to notice. What are the different ways seeds are designed to disperse or travel? Number 3, very important, be creative. How can we explore the variables involved in our different helicopters as we build them? How can we change those variables? How can we create something new? And number 4, to wonder. What are the different seed designs? Why are they different? How do their designs relate to how they disperse? We at the Ames Center, we love to play. So what about seeds? Well, it is all about survival. For a plant to have a better chance of surviving, its seeds needs to find ways to move away from the parent plant. But there's an energy cost to producing a seed. We have it costs energy to do that. And so there's a delicate balance between figuring out how many seeds do you produce, how are they going to travel away from the plant, what is their germination rate, do you produce 1 seed, do you produce 1,000 seeds? Different plants approach it differently. But seeds have found a very unique way of ensuring a wide geographical distribution. They have found better ways to move from the shade underneath a tree, say in the jungle forest, to areas where there is sunshine, sunlight, and ways of traveling to discover better sources of nutrients to allow that plant to survive. So what I would like you to do is, for the first thing to do is to write down as many different ways you can think of how seeds can travel. Think of different seeds, what their different shapes, how do they travel from one place to another? I'll give you 3 minutes to do that, and then we'll talk about it. Good, we're seeing a few things. Wind, animal poo, kicking around by feet, water, ooh, insects, that's a good one. Birds, absolutely. Animals absolutely do carry seeds to their home. Good, any others? Excellent. People do transport them to other places, absolutely. All right, so we could go to the next slide. So before we get to our helicopter, what we're going to do is design our own traveling seed pod. Our goal is to create a seed pod that travels the furthest distance. So what I would like you to do is to take an 8x10 sheet of paper, cut it into quarter. It doesn't have to be an 8x10 piece of paper. It could be any paper you have. Just cut it into 4 equal pieces. And you're going to use those 4 pieces to design a unique seed pod. And you're going to use 1 breath per pod to try to blow it the furthest distance you can. So think about 4 different designs that you can create to send your seed pod across the table or across the room.
So Steve, am I hearing you? So divide a piece of paper into 4 sections and then design a seed pod out of each.
So you have 4 different seed pods.
Can we, so just using 1 breath, can we do anything to amplify our breath or just a blow? What, just 1?
Well, if you amplify it, you want to amplify it for all 4. The key is to see how far the seed will travel with the same breath.
Got it.
Other questions? So we're using the same key is we're using the same amount of material and we're creating a seed pod, different shaped seed pod that will act differently with the same propulsion.
Tonight you're mine. You give your love so just a moment. Pleasure. Can I breathe the magic of your size? Will you still love me tomorrow? Tonight.
Just another minute or so.
Heard there was a secret chord that David played and it pleased the Lord. You don't really care for music, do you? Well, it goes like this: the fourth, the fifth, the minor fall, the major lift, the baffled king composing. Hallelujah. Hallelujah, hallelujah, hallelujah. Well, your faith was strong, but you needed proof. You saw her bathing on the beauty and the moonlight only through you. Well, she tied you to her kitchen chair. She broke your throne and cut your hair. And from your lips she drew. Hallelujah. 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 Baby, I've been here before. I've seen this room and I've walked.
Okay. What have we found? Does anybody have some unique seed pods? What kind of designs have you come up with? Elin, what did you come up with?
I just based on my own experience, I thought the first one I just crumpled up into just a ball.
One of those two.
And then I yeah, just like is I think we have some people sharing in the chat. I made one that I felt like had a tail, like I've seen seeds before. And then some that had like just more flappy, like, and actually the two that I made that had things that were like open and sticking out, or more surface area, actually went further than the ones that were like just bald, like more, I guess, denser, I would say. Just like we have one of our participants sharing, I think Marina, the one folded like a fan traveled further than flat pieces. So yeah, I found the same thing, one that had some folded pieces, but like open, went farther when I glue on it.
Good. And I made a boat and a paper airplane, made an airplane. Someone made a cylinder. Cheryl
Yeah.
made a cylinder that was closed at one end and open at the other. Good.
Right. Oh, an airplane, like folded like an airplane. That's, yeah.
Yeah. So what I like about this is we're building from our experience. We're designing from our experiences, right? And like you said, Elind, you thought about what the seeds that you have seen, what did they look like? And the seed pods they look like, and we designed from that. Yeah, I tried one where I crunched it up into a very tiny ball, and then of course tried one where the did not crunch it up quite as much, gave more surface area, and of course it did travel farther, but tried to make one that looked more like a sail that would catch more of the wind and the force behind the wind and cause it to fly. And that's what seeds do, depending on the seed pods are built for different modes of travel. And that's what we're going to look at today. So here's a chart that I just pulled off did a Google search, pulled it off the internet, of different ways that seeds can travel. And very different seeds travel in very different ways. They can travel by wind, they can travel by animals, by either sticking to them or being eaten by them, as some of you mentioned. There are seeds that travel by water. Some actually explode. The seed pods explode and eject the seeds and throw them a distance away. And also seeds are moved around by humans, right? Wheat and cherries and beans and those type of seeds, we move from place to place and plant them based on how tasty they are, maybe we can say. And of course, there are many seeds, weed seeds that we have, which, and as my wife would say, many weed seeds in our backyard that stick to the animals, and we have to brush them and comb them and try to get all those hitchhikers off their fur, out of their fur. So let's look at a few of these different types. Here we have seeds that can travel by being eaten. As I said, boysenberries are in season now. I'm starting to pick those. Blackberries will be very soon. I pick boysenberries every morning, but inevitably I'm sharing some with the birds. The birds eat those tasty fruits and spread their seeds near and far. Mulberries too. I don't know if we have a small dog that we walk, and those mulberry trees in our neighborhood, they're all producing mulberries, and they're all over the sidewalk, and those seeds are being spread. Acorns, of course, are picked up off the forest floor by squirrels and raccoons and skunks. They're carried away. Sometimes they're stored for winter. Sometimes they're buried. If a squirrel doesn't remember where an acorn is buried, there's a chance then that it germinates and sprouts a oak tree someplace new. In the valley here, we have lots of date palms. Date palms are a favorite of many, many animals. And this time of year, we find date palms scattered out on the yards and the sidewalks. I have always seemed to be digging palm trees out of my backyard. I don't have a palm tree in my backyard. So I don't know how they're getting there, but somebody is planting them. Seeds can travel by water. One of the best examples here is a coconut. Coconut palm trees have successfully developed and evolved to live by oceans. And because of their ability to be able to change salt water into fresh water. Now, a coconut's huge. There are a limited number of ways a 2-pound coconut can travel. Certainly a squirrel can't haul it very far, right? But what we found is that a coconut can float and thus travel by water. We have found that coconuts can survive in water for over 3 months, and they can travel for over 3,000 miles and still be able to germinate. Really is quite amazing. Seeds can travel by hitchhiking. There are over 600 weed seeds that travel by hitching a ride on humans, animals, or vehicles. There are 248 species, which are considered invasive species in North America. In other words, weeds. Many of these hitchhikers produce many seeds. Unlike a coconut tree, which only produces a few coconuts at a time, a hitchhiker can produce hundreds of seeds at a time. And by hooks and barbs and spears and burrs, they attach themselves to our socks or our shoes or animals' fur and can move from one place to another very effectively. Velcro is an example of biomimicry, of us being, as humans, looking at how nature does it. And someone I believe in 1952, looked at some of these cockleburs or burrs and how they were attaching themselves with little hooks and designed Velcro, which we have used very effectively and successfully since then. As I mentioned before, seeds can travel by exploding or bursting. Ballistic seed dispersals is where a plant seed pod ejects their seeds anywhere from 3 to 15 feet. It builds up a large force or a large pressure as the pod dehydrates, as it becomes drier. It builds up a force, and when that pod finally breaks, those seeds then are dispersed. There's several examples here in the valley those plants that do that. Touch-me-nots, patience, wood sorrels. There's a firecracker plant, and even violets. I did not know violets did that. My mother grew violets. My grandmother grew violets for many, many years. But evidently some of them can eject their seeds. And finally, seeds can travel by air. There's a vast variety of methods for that seeds can travel by air over great distances. I grew up in Kansas on a farm, and along creeks and rivers, we had cottonwood trees, and they were called cottonwood. These are trees that would grow to be 100, 150 feet tall. And we called them cottonwood trees because when they produced seeds in the spring, it was this very fine cotton, looked like cotton out of a stuffing bag. And it would, for about 2 weeks a year, these giant trees would produce this cotton and these seeds, and it honestly would look like it was snowing, because they would just float across, snowing, but the snow never disappeared. It would collect and gather in radiators and stuck in weeds, but they could, in the wind, they could travel for dozens of miles, if not hundreds of miles. Of course, we're used to seeing lots of dandelions, and who hasn't picked a ripe dandelion and blown its seeds across the sidewalk when you're going home from school? But there are other seeds, like the one on the right-hand side here, which looks more like an airplane, looks like a glider. It's called I'm not going to remember the name. Aerosense or something like that. I'd have to look it up again. But you can look up a YouTube video, or go to YouTube and type in seed gliders, and you'll find this beautiful seed floating through the forest. It looks just like you've thrown a paper airplane. It really is amazing. And of course, the bottom picture there is a milkweed seed, a seed attached to a very silky or feathery top. Milkweeds are, of course, the favorite plant of the monarch butterfly. It also, if you look, it's very similar, of course, the model of the milkweed was used as a model for the seed that is in Avatar, the movie Avatar, the one that lights up and glows up and seems to collect on his arm. I always look at that and say, that looks just like a milkweed seed.
Almost looks like an insect.
It really does, doesn't it? Okay, so I've talked too much. Let's do some building. Activity 2 is building our paper helicopter, building and designing our paper helicopter. So our goal is to create an experiment with a simple paper helicopter design that represents a whirligig type seed, such as a maple seed. So again, you can use a 3x5 piece of paper or a 3x5 index card, common index card. Size really doesn't matter. You could use origami paper, you can, a gum wrapper, it can be square, it can be rectangle. It is your choice. And you're going to use that material to build an helicopter. And Elin, if you'd like to describe how we're going to do that.
Sure. Yeah, I have my dot cam set up, so I will go ahead and switch my view. See, I might have my C prototypes over here that I was playing with. So I'm using an index card, and what I like to do is just sort of divide it into, or fold it into thirds. So I have a guide to think about where I'm gonna draw my lines. And then I am gonna use just a marker so you can see. And where we're gonna cut. So on one end, we're gonna start and cut almost all the way to the end, leave about a quarter of an inch, or not a quarter, like almost 3/4 of an inch, or leave about a centimeter, and then come from the other side and cut all the way to the end, almost all the way to the end on that side. Yeah, it's interesting. We're really, it's thinking about especially seeds that are carried by the wind, how nature has done some adaptation, and in terms of engineering, like how has nature engineered seeds to move with the wind, or by travel, like the grabbers that you were sharing. It's really interesting to think about engineering in nature, like design. So I'm going to take scissors and just cut. And then you can see it sort of looks like an S or Z. And then I'm going to take those, pull them down, and use a paper clip to fasten that. And you can explore with the way you fasten it, whether you just connect them just touching, bringing them in and touching, or if you want to try overlapping, and then hold it up and drop it and see what happens.
Excellent. Can't be simpler than that.
Yeah.
I love that design.
Yeah, and like Steve, like you were saying, you can really explore with a lot of different types of paper, origami paper. Again, this is just an index card, but you can use just regular copy paper and see what happens. That's part of the fun of exploring, and trying different. I I'm using a paper clip, but what happens if you staple it at the bottom? Does adjusting the weight make a difference?
Right. And that's what I'd like us to do for the next 10, 15 minutes is I want you to play with your design of your helicopter. And I'd love for you to experiment with it, see how build your first version and see how it works. How does it spin? Can you just drop it? Can you throw it? Play with it a little bit, but then adjust your design. What happens if, what are the variables in our experiment? What things can you change? What things can you control? It's a very simple design for this particular helicopter, but there still are variables that can be explored within that design. So what about size? What if you drastically change the size of your helicopter or your piece of paper that you're using to make your helicopter? What about the composition of paper? What if it's made out of wax paper or index card versus a sheet of paper versus tissue paper versus origami? Or you change the width of the blades so that the blades are much larger than the stem, or the stem is much larger than the blades, or the number of paper clips you add or subtract, or you use a staple versus a paper clip. All of these variables, slight changes in variables, do make a difference. And I'd love for you to experiment with some of those variables with those different designs. Think about how you might do that in the classroom. And let's take some time to create your own helicopter design and think about how that changes how fast it spins, how well it falls. Let's see what those variables, what's those changes give us. Any else I should add, Eland?
No, but I'll turn my doc cam on again and I'll I'll experiment with some more prototypes. Just I'll explore along with everybody else. So I'm going to switch now, and Steve, I'll trust that you'll be the timer.
I will be the timer. I'll watch the chat if as people have questions. I'll put on some music and build some helicopters as well. Let's have fun with it. All right, how's everybody doing? Do you have a squad of helicopters by now?
Yeah, I'm just curious to see if I would love if people share in the chat to see what they've been exploring with. Steve, I saw in the chat that you were asking or challenging us to do a helicopter with more than 3 blades. Was that one of your?
Yeah.
Yeah, which I tried, and so I don't know if you can see, I was experimenting with this, but I found it didn't work as well as the one with 2. I feel bad that people can't see. I've been pulling it away and dropping it to test it, but this one with 3, for some reason, and I think it's because maybe there's a different weight, like it has, so it has to be weighted on each side equally. So this one works really well where there's just 2. I was gonna try this one, but just maybe so it actually has 4, but again, each side has the same amount of weight. Or
Good. Yeah, and maybe twisting the blades a little bit or giving it a different, what we call pitch, giving a different pitch might make a difference.
right.
I don't know.
Right. Let's see, I'll try it.
And what I found is the weight is very important. The amount of weight on that stem versus the size of your helicopter is actually pretty important.
So the amount of weight, like a paper clip,
Yep.
to me works really well. And again, I'll try this one with. It still works without the paper clip, but it just, it doesn't spin as fast. Just don't get the I don't know, just the momentum. Another thing I tried with was this design, that first one we played with, doing it on a diagonal. I tried with the bigger piece of paper and it works. It probably would fly or spin more if you had a higher, like if I had a higher height to drop it from. But it's interesting to me. This one is very much like a glider. Reminds me of like a hang glider. And so when you do it on the diagonal, you still have that glider like look, and you still have this central point where you're putting the weight. So because I tried making it, I tried with this one making this middle part wider and the pieces you pull down thinner.
The stem very thin.
And it still works. And the same thing with this, a diagonal, you still have that triangular shape with the weight on the bottom. So it still works. This one still works, I think spins the best, but these still spin as well.
And those are all out of the index cards you're using.
Yes. Yeah, I'm wondering if anybody experimented with different types of paper, use different types of material. Again, I use some of the I just use some regular
copy paper.
And my next I guess iteration would be to use smaller pieces of that, but for the sake of time, I had index cards, so I just started playing with those.
Anybody else try a different variation? I have to say I'm a little enthralled with this in all the different variables that we can try to control. Cheryl used a sticky note and was fine with a paper clip. Good. An extra large binder clip causes an epic fail.
Yeah.
Well, like I
Interesting.
said, the weight does seem to be very important, and I'm intrigued by the spin rate of these helicopters and how changing the variable just slightly really changes that spin rate. There are many different helicopter designs that we can make. Some of you maybe have made paper helicopters before. Certainly you can find templates online to do just that. I like this design that Elin found, that it is just so simple, two cuts and hardly a fold to generate a helicopter. But I looked online and found many variations of 2-blade, 3-blade helicopters. You can even build them out of paper cups and make as many blades as you want, I suspect. And they all act a little bit differently depending on their rate. Laura says that if you attach a lighter weight paper to your design, would the rate of movement be affected? That's a good question. I've been trying to figure out how I might be able to explore that. And one thing I thought about was if I take the one blade of my helicopter, just one, and put a spot on it. And then when I drop it, I'm intrigued to see, I'm going to try this, is use my cell phone and put it on slow-mo and drop my helicopter and see if I can count the spin rates of my helicopter from a certain distance. And that gives me a way to quantitatively be able to count calculate the spin rate, or be able to identify the spin rate, and be able to compare different helicopters. We all have these fancy cell phones. We might as well put them to use, right? These smartphones.
So Steve, what did you use for the weight on one side?
I didn't add a weight. I just put a spot. So identifying mark.
You can, yeah, got it.
Yeah. So you can in that case, so when it spins, I can hopefully, if it's spinning slow enough, be able to see that spot as it goes around. But you can also color your helicopter and the blades of your helicopter with different colors. And when it spins, you get a mesh of those colors mixing together in patterns. Could be quite interesting to do something like that.
Yeah, I love that one made with the paper cup. That's clever. I want to try that.
Looks like fun, doesn't it?
It does.
This whole idea of talking about seed dispersal really came from a video that somebody sent me about the African Sharia tree. And here is a seed pod from that tree. And it's hard to tell size because we don't have a scale here, but these are really big seeds. And if you look up a video of them, Google a video of the Sharia tree, you find that these really large seeds, and it has multiple blades on the seed pod, and they really fly like the paper helicopters that we're dropping. It's amazing how much they look like that as they're falling through the air. And so that I started to think about, I knew about maple trees and certainly as a child played with maple seeds and how they drop, which is also very interesting. We were talking about that on the chat. How does a maple seed has only one blade? I have yet to be able to create that as a helicopter. So there's some interesting physics going on there with a maple seed to be able to make what I would call a whirligig, a spinning seed like that I can't reproduce, but I'm going to try, see what I can find. This kind of activity, I think, is very STEAM, very steamy, as I would call it. That it's where the science, the technology, engineering, art, and math can overlap and give us room to play. Certainly the science, we talk about the biology of seeds dispersal and seeds and dispersal scattered all through the K-8 curriculum, science curriculum. Technology in terms of biomimicry and how these seeds are similar to Velcro, or how Velcro is invented, how they fly like a paper airplane or a helicopter. The engineering part of changing the design and seeing how the adding different weights or different lengths of blades and how that affects our helicopter and how it flies. And of course, art, we can decorate our helicopter, be able to give different patterns, which changes when it spins, use a camera or slow-mo camera to be able to see some of those colors and color mixing. It's actually quite interesting. And of course, in mathematics, even though there's only 2 cuts in a piece of paper, we can talk about proportions. We can talk about fractions, cutting the paper into thirds. How far do you cut make the cut through the index card or the piece of paper? We can bring in this math vocabulary and integrate that with the other areas of STEAM. And of course, within the NGSS or practice standards, there's this vein that travels throughout the science standards that talks about developing and using models, asking questions and defining open-ending problems, planning and carry out investigations. All can be done with the paper helicopters and similar type of activities. For the younger grades, there are books that connect with seed dispersal. I just did a quick Google search and found Seed Moves by Robin Page. There's one on seed dispersal that comes from Scholastic. Joseph Anthony has written a book called The Dandelion Seed. It is a way for us to connect literature with science, literature with our STEM activity or STEAM activity. Well, our time is up. I hope you had fun. I certainly did. I enjoy playing with this type of activity and open-ended, and there'll be lots of room for making changes and exploration. I hope you can use this type of activity in the classroom, and as you do, please send us pictures, send us a note of what the kind of things that you've done. We would like to mention that there is a early math symposium, which is open for registration today. And the symposium is in June. Ames will be presenting at the symposium. We're doing a few different sessions. There'll be lots of other folks presenting. There is ability, or it's going to be lots of fun. You can go to the ames.org/symposium 2022 and be able to register for that symposium or direct it to registration for that symposium today.
Yeah, and I believe it's June 24th, and registration is free. It's a free event. So
it is free events, which is so rare.
It's really a lot of fun and a lot of great learning going on. And we encourage everybody to register and attend. It's a lot of great learning, a great day of learning.
Well, thank you so much for attending. If you have any, do any paper helicopter work in your seed dispersal in your classroom, please think about sending us pictures. And we'd love to see what you're doing. Well, we do have what we call one-pager activities that describe building these helicopters and these different designs. You can go to aimscenter.org and be able to download those one-page activities that you can use in your classroom. I think that's all we have. Elin, do you have anything that we need to cover yet?
No, thanks for joining us. I hope everybody has a great afternoon.
Have a great afternoon. We'll see you next time.